let's consider a box sitting on a flat surface and a box sitting on an inclined. A box sitting on a flat surface and also a box, let's consider a box is sitting on an incline. The gravitational force acting on this box, the gravity has only one component, and that is Fg. The gravitational force acting on this box has two components. So let's draw the Fg and show you the two components. This is Fg. This Fg has two components. This is Fg perpendicular, and this is Fg. This is Fn. This is only one component, and I'm going to show you the other component right now. And this would be Fg parallel. Fg parallel and F friction. Okay, so I'm gonna solve this problem because many physics students having trouble solving this two type of problems. Sometimes they mix it up. So so if you do understand this, how to solve this two type of problem, then you'll be able to understand the difference very quickly and solve the problem very quickly. Now let's see the first box. Let's say this is 20 kilogram. 20 kilogram. Let's say someone is pulling force is, let's say pulling force is 90 Newton, and someone pulling it, applying 90 Newton at 30 degree. Now let's say the mu k, the coefficient of friction, kinetic friction, is 0.5. What do we need to find? We need to find the acceleration. And let's say this box is 3,100 kilogram. Let's call it mass 1, and let's say mass 1 is 3,100 kilogram. Let's say this box is hanging on a rope. This box hanging on a pulley, and there is another box attached to the string. And let's say that box is 1,000 kilogram, and let's call it mass 2, and mass 2 is 1,000 kilogram. And let's say there are friction, the friction on the incline, and let's say that the coefficient of kinetic friction is mu k is 0.1. What do we need to find? We need to find acceleration. We need to find the acceleration of this system and acceleration of this system, and along the way we'll understand the difference between these two and how to solve these two type of problem, because sometimes physics students mix it up. Okay, so let's first solve this one. And the first thing first, we have to find the weight. The weight is mg. M is 20, and g is acceleration due to gravity. And as you know that acceleration due to gravity has two components. I always remind my student, the acceleration due to gravity at the x direction is 0, and the acceleration due to gravity at the y direction is negative 9.8 meter per second squared. For to solve this problem, we're going to use 9.8. Okay, so let's write 9.8. So 20 times 9.8, let's take my calculator. 20 times 9.8, is 196 Newton. Okay, now we found the gravitational force acting on 20 kilogram mass. Sometimes we call it weight. So we can say weight. So weight of this box is 196 Newton. Okay, now we have to find the normal force now. Before finding the normal force, we have to find the both component of the pulling force. Now, as you see that the pulling force affecting the normal force. If I remove this string, the weight of the box would be equal to normal force. That would be weight of the box is 196 Newton, then normal force would be 196 Newton. But now the normal force would be less than 196 Newton is because someone is pulling it, applying 90 Newton at 30-degree angle. So the pulling force will affect the normal force. The table realized that the box sitting on this table, someone applying some force at 30 degree. So all of a sudden, table has his own mind in the world of physics. So table decided to push it up, applying less force. Only the force is need to apply. It apply only that much. Now let's see what is the normal force. It has to be less than 196. Let's first find the both component of the pulling force. Fx and Fy. Fx is 90 cosine 30 degree and Fy is 90 sine 30 degree. Okay, let's see. Cosine 30 times 90 is 77.94 Newton. Let's see this one. Sine 30 is 0.5 times 90 is 45. So this is 45 Newton. Now this one affecting the normal force, the table apply 45 less Newton. If you remove that string, then obviously table has to apply 196 Newton. But now table apply 45 less Newton than it has to. So then let's find it, normal force. Normal force is equal to the weight of the box, 196, minus the y component of the applied force. The y component of the applied force is 45. 196 minus 45 is 151. So normal force is 151 Newton. So now we're going to find the friction, the force of friction. So let's find the force of friction. By the way, force Aristotle wrote that the moving object in motion slow down because they get tired. Now, Sir Isaac Newton said that no. Object in motion slow down is because of friction. These boxes, someone is pulling it. The box is slowing down is because friction. Now let's find the friction. Mu k in Fn. So mu k is how much? Mu k is 0.5. And Fn is how much? Fn is, we already found it, 151 Newton. So 151 times 0.5 is 75.5. 75.5 Newton. So that is force of friction. Now, someone is applying how much force to accelerate the box at the x direction? 90 Newton. But at the x direction, not 90 Newton, all those contribute to the acceleration. Only the x direction. So x direction how much? About 78 Newton. But not 78 Newton contribute to the acceleration is because some of the force are frictional force. So the net force is contributing to the acceleration. Let's see what is the net force. Now net force is net force is X. This is the X, 77.94 minus, this is the friction, 75.5. 77.94 minus 75.5 is equal to 2.44. So 2.44 Newton, although this guy pulling it 90 Newton, only 2.44 Newton contributes to the acceleration of the box. Remaining forces, some went to the y direction and some wasted due to the friction. So now we can find the acceleration using Newton's second law. So Newton's second law is F equal ma, but it's actually F net equal ma. So acceleration is, of course, what? F net over m. F net is 2.44 divided by 20 kilogram. 20. So 2.44 divided by 20 is 0.122. So it's 0.122 meter per second square. So this box is moving to the right 0.12 meter per second every second. It's because there is a net force. If net force was zero, net force is zero at the y direction, but if net force was zero at the x direction, then there would be no acceleration. Since there is some net force, there is some acceleration. That's what Newton told us. Okay, now a little bit more complicated problem now we're going to solve, and we're going to solve it together, and hopefully you will fall in love with how to solve physics problem. Solving physics problem is the best thing you can ever do as a human being. All right. Okay, now we already broke it down into, we already divided into two components. The gravity has two components. Now let's first find the weight. What is the weight? The first thing I always do, find the weight. mg. What is m? M is 3100. G is 9.8. So 3100 times 9.8 is 30,380 Newton. So this is the weight. This is the weight of this box. Now the gravity has two components. Is because it is sitting on an inclined plane. So now let's find both components. So Fg has a two component, Fg parallel and Fg perpendicular. Fg parallel is by definition Fg sine theta. And let's say this is 30 degree. The angle is 30 degree. It is 30 degree inclined. All right. And this is Fg cosine theta. Now, what is Fg? 30380 times sine 30 degree. And this is 30380 times cosine 30 degree. Now let's see, what is it? Times sine 30. 15190 Newton. Now let's see other one. 30380 times cosine 30. 26309.85. Okay, now we found the both component of the gravity. What can we do with that? We can solve the problem. It is very interesting. Okay, now let's find the force of friction. The force of friction is, again, the force of friction, slow it down. This object is heavier than this object, so this object is moving this way. Now what's slowing it down? Again, the friction is slowing down. Again, this one also slowing it down. If I remove this one would be accelerating faster. Since I'm not going to move this one, I would not put it to remove it. I put it to make the problem a little bit more interesting. So now let's solve the problem as it is. Okay, great. Force of friction. Force of friction. Force of friction is mu k Fn. All right. What is our mu k? Mu k is 0.1, and Fn is, what is Fn? Perpendicular component is also called Fn. So 2630985 times 0.1, and that is 2630.98. Okay, that is the force of friction acting on it. And what can we do with this one? We can definitely now solve the problem. We're gonna write M1 and M2. Okay, so let's draw the M1. Let's see how it look like. So M1, let's draw the M1. How many forces acting on the M1? At least how many forces contribute to its acceleration? Well, this is FG parallel. Okay, this is FG parallel. This is FG parallel. Okay, we check. This is FF and this is FF. We check. Ah, there is one more force. Tension force. So FT. Where the tension force coming from? This rope. If I remove it, there would not be any tension force. But I'm not gonna remove it. I don't want to make the problem less interesting. I'm gonna put FT over here. Okay. Now Newton's second law gonna save us. So Newton's second law is F equal to ma. Now F is all the forces that contributes to the acceleration of the box. Now what are all the forces? You have FG parallel, negative, because this is not contributing the acceleration. This is slowing it down, so that's why it is negative. FF minus FT is equal to ma. Now wait a minute, we know FG parallel is 15190. We know FF is 2630.98 minus FT is equal to, we know M. What is M? 3100. 3100A. All right, we almost have a beautiful equation. Great. Excited. 15190 minus 2630.98 is equal to 12559. 12559 minus FT is equal to 3100 acceleration. This is awesome. We found a nice, beautiful linear equation, so that once we have the other equations, we can cancel FT. Canceling FT would be our priority. Now, let's talk about the box number 2. What's going on? This is mg, right? M is what? 1000. Times G is what? 9.8. So 9800 Newton. Okay, so How many forces acting on it? 2. One downward, Fg. One upward, Ft. We call it tension force. We call it tension force. Okay. Now let's solve it. Great. We're gonna do it over here because we kind of out of space. Running out of space. So we're gonna draw the box here. Alright. How many forces acting on this box? Let's put 9800 here. 9800 here. 2. This is Fg and this is Fn. How are you doing? Good? Alright. Now we're gonna write Newton's second law again. F equal to m. Alright, now we're gonna put a sigma telling the wall that we're gonna include all the forces contributing to the acceleration. That is, all the forces at the y direction. Good. All the forces at the y direction. What are the forces at the y direction? Super obvious. Fn minus Fg is equal to m. We know. Oh, this is not Fn, this is Ft. Ft. So Ft, we know Fg. 9800. We know m, and that is how much? 1000. Alright, so we found another beautiful equation. Okay, so now we're gonna write this equation right over here. So for M2, what do you get? Ft minus 9800 is equal to 1000A. Alright? Okay, so that's what we got at over there. So what is our, this is, now we're gonna put this one over here. We can rewrite this equation a little bit differently. We can put a negative Ft at the beginning and then plus 12559 is equal to 3100 acceleration. What are we gonna do now? We're gonna write minus Ft plus 12559 is equal to 3100A. How are you doing? Okay, now Ft cancel, obviously. Let's see what we get. 12559 minus 9800 is 2759. 2759. I'm excited, very excited. Hopefully we'll gonna solve it quickly soon. 0 so 0 0 1 4 41008. All right, so A is equal to 2759 over 4100. So 2759 divided by 4100 is 67. You see that? Ah, this is so beautiful, 0.67. So acceleration is 0.67 meter per second squared. Okay, so we'll end here. Thank you for watching.